The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting, but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All right, so we've got a couple of questions from yesterday's homework in 10.1, and then eventually we're going to start 10.2 part 1. But let's take a look at the questions. This was, okay. This was 10.1, and this is number 5 from this particular student. And I want to put it up on the screen here. So this is number 5, which I've got here with the arrow. Fill in the blanks to factor the perfect square trinomial, okay? And part A, it says x squared plus 8x plus 16, and it equals x plus something. And then the second one, part B, is x squared minus 3x. Actually, you know what? Hang on. I'm going to put that on a different page so that we have lots more room. Give me just a minute here. Part B says x squared minus 3x plus 9/4 equals x minus something squared. Okay, so now I'm going to go back to my whiteboard. All right, now there's a couple of ways we can approach this. We can just take x squared plus 8x plus 16 and factor it. And when we do that, we discover that it's a perfect square and we get that and we're done. Another way we could do this is we could go back to what we looked at yesterday in terms of how we create a square. Well, let's say we just had that, okay? What would we do? We take the 8, divide it by 2 and get 4. We take the 4 and square it and get 16 and add it there. But recall that what I said yesterday was that the number that went in here was this number. So that would be a plus 4. Now, for this example, doing it the first way was probably easier, but let's take a look at the second example, this one, okay? Now, I could try and factor this thing, and it wouldn't be too bad. Maybe, let's see, if it's a perfect square, well, the square root of 9 is 3, and the square root of 4 is 2, and we'd come up with that, and that would be correct, okay? So really, that's not too bad. But the other way you could do this is you could say, well, to get this term here, I'm going to take that divided by 2, which is that, and then I'm going to square it, which is that, and then I'm going to add it, 9/4, okay? But remember, this thing is what goes in there. So you can do it that way. Either way works, no big preference. Any questions on that one before we look at another one? Okay. Here's another problem where it just says complete the square and factor the resulting perfect square trinomial. Okay, so we've got x squared plus 4/7 x. So to complete the square, we're going to take the coefficient of x and we're going to divide it by 2, which is the same thing as multiplying it by 1/2, which gives us what? 2/7. We're going to take 2/7 and square it, which gives us 4/49. Okay, and then factoring it, we're going to get x plus 2/7 times x plus 2/7, or x plus 2/7, the quantity squared. You okay with that? I'll take that as a yes. Okay. And now we're going to go to look at another person's same question. So hang on. Let's see here. 10.1. Come on. And number 15 again. Okay. And let's see. Let's look. This one, it says complete the square and factor the resulting perfect square trinomial. We've got x squared plus 2/5 x. So we're going to do the same thing we did before. We're going to take the coefficient of x and we're going to divide it by 2, which is like multiplying it by the reciprocal, which is 2/10 or 1/5. We're going to take 1/5 and square it and get 1/25 and add that. So that completes the square. Then the factors will be x plus 1/5 times x plus 1/5, or x plus 1/5 the quantity squared. Are we okay with that one? Any questions there? All right. Do you have any other questions you'd like to look at before we go on to the new section?
Can we go over number 21?
21, okay. And let me pull yours up here. Let's see here. Oh, you're in the other class. Okay. So this is 10.1, number 21.
Yes.
Okay. Okay. So it says, use completing the square to solve the equation. Enter your answers as a comma-separated list. And so this is number 21, and we have 35t squared minus 18t minus 5 equals 0. Okay. All right, so now let's look at the whiteboard. Since my leading coefficient is not a 1, it's a 35, I've got to go in and divide each piece, each term by 35. Okay, so now I get t squared minus, well, let's see, can I reduce negative 18 over 35? 35 is 5 times 7. Neither one of those go into 18, so this is going to stay negative 18 35ths t, and then minus 5 over 35 reduces to 1 over 7 equals 0. Okay, so the first step, we divided by a, by the leading coefficient. Any questions there? All right, now we're going to take negative 18 35ths and divide it by 2, which means we're going to take negative 18 35ths and multiply it by 1/2. I can pre-reduce that down to negative 9 35ths. Okay. Let's see. So now I've got that. What am I going to do next to that? Square, right? I'm going to square it. So I'm going to get 81. This just seems, hang on a second. I feel like I've done something wrong. Maybe not, but I want to double check things here. 35, 18 over 35, 1 over 7, 0. Take that, cut it in half. 9 over 35. Yeah, that's 81. And then 35 squared is 1225. Huh. That just doesn't seem right. Oh, I know what I forgot to do. It doesn't affect things, but before I did all of this, I should have added 1/7 to both sides. So I'd have t squared minus 18/35 t equals 1/7, okay? That doesn't affect what I just did, but now I'm gonna add 81 over 1225 to both sides, okay? You still with me?
Yes.
Okay.
Yes.
So on the left side, I've got t minus 9/35 times t minus 9/35, okay? Which is t minus 9/35 squared. Is everybody okay where I got this from right there? Just like we exemplified in the last couple of problems. But now I've got to add those together. And I have a common denominator of 1225. Let's see. If I take 1225 divided by 7, I get 175. So that means going the other direction, I need to multiply by 175 over 175, which gives me 175 over 1225 plus 81 over 1225. Which gives me 256 over 1225. Okay. I know this thing got ugly really quickly with the big numbers, huh? We okay so far?
Yeah, that's what I was confused on, was the big numbers.
Yeah, I know. That's why I was kind of like, am I doing this right? Okay, I'm going to recopy that on the next page. T minus 9/35 squared equals 256 over 1225. Take the square root of both sides, and you get t minus 9/35 equals plus or minus. Well, let's see. What's the square root of 256? That's 16. What's the square root of 1225? That's 35. Oh, nice. So then I'm going to add 9/35 to both sides. T equals 9/35 plus or minus 16/35. So t equals 9 plus 16/35. T equals 9 minus 16/35. Let's see, 9 plus 16 is 25/35, which would be 5/7. 9 minus 16 would be negative 7/35, which is negative 1/5. So t equals 5/7, comma, negative 1/5, which are the correct answer. Yeah, boy, that was big numbers there. Okay. SB, you all right with that?
Yeah, sorry.
That's okay. All right. Any other questions before we go on?
Did you do number 29 by any chance? I came late.
Okay. Let me find that here. Hang on. Let's see. Okay. Oops. Okay, this was 10.1. You said 29, was it?
Yes.
Okay. solve the equation. Huh. Okay, okay. It says solve the equation, enter your answers as a comma separated list. And the equation, so this is what, number 29 from 10.1. The equation is 7x squared over 8 equals 1/8 minus x. Okay, so my first big goal is to get this in standard form. So I'm going to put everything on the left side of the equation. So I'm going to add an x and subtract 1/8. So that's going to give me 7x squared over 8 plus x minus 1/8 equals 0. Okay? All right there, Paula? All right. Then we're going to multiply both sides by the LCD, which is 8. So 8 times 7/8 x squared is 7x squared. 8 times x is 8x. 8 times minus 1/8 is minus 1. So I get 7x squared plus 8x minus 1 equals 0. Any questions about that?
No.
All right. So now going to the quadratic formula, A is 7, B is 8, C is -1. So we get x equals -8 plus or minus the square root of 8 squared minus 4ac all over 2a. X equals -8 plus or minus the square root of 64 plus 4 times 7 times 1, negative times positive times negative is positive 28 all over 14. X equals -8 plus or minus the square root of, let's see, 92 over 14. Okay. Now, I can simplify, or at least I'm going to try and simplify the square root of 92. Let's see, the square root of 92. 92 would be 2 times 46, which is 2 times 2 times 23, or 4 times 23, which would be 2 square roots of 23. So x equals -8 plus or minus 2 square roots of 23 all over 14. Okay, I'm going to take that expression and go to the next page. X equals -8 plus or minus 2 square roots of 23 all over 14. Now, if we get this situation and this term, and this term all share a common factor, do you see that they're all even? So they all share a common factor of a 2. We can reduce this thing down. And what I'm going to do, I'm going to factor a 2 out of the top, and I'm going to factor a 2 out of the bottom. So this is going to be -4 plus or minus the square root of 23 and a 7. Okay, so here's your -8, and here's your 2 square roots of 23, and here's your 14. Then I can reduce that down. So I get that. Okay. Now, your answers, you'd put x equals, let's see, you'd go -4 plus the square root of 23, the whole thing over 7, comma, -4 minus the square root of 23, the whole thing over 7. Make sure your comma is not down here with the 7, but is out there separating the two big fractions. All right with that?
Yeah, thank you.
You bet. Any others before we go on?
No.
Okay. Then let's go. So, and making sure I've got my right screen up here. So we're going to take a look at section 10.2, part 1. And for the sake of time, rather than going through the whole process, I'm just going to say, if you take a general second degree or quadratic equation written in the form ax squared plus bx plus c, where a, b, and c are its coefficients, and you put it through the process of completing the square. So you divide everybody by a, then you'd move the constant over, then you take the coefficient of x and divide it by 2 and square both sides and add it, and all those steps, what you come up with is this: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That is called the quadratic formula. What it allows us to do is to solve second degree equations by methods other than factoring. Okay, so we can solve it. In fact, some of the equations that we couldn't factor, we can solve this way for some of the polynomials. Okay, so this is called the quadratic formula. You want to have this thing memorized. I'm going to start out with with an example and show that factoring it, this is what we get using the quadratic formula. This is what we get, just to show you that, yeah, it works, and then we'll go on from there. Let's say I had the trinomial x squared plus 5x plus 6, or the trinomial equation, okay? If you were going to solve that by factoring, you'd get that. Is that correct? I think so. And you'd come up with x is -3 and x is -2. Okay? Now, I'm going to use the quadratic formula on this to come up with those two answers. All right. So A is 1, B is 5, and C is 6. You okay where I got the A, B, and C? So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals -5 plus or minus the square root of 25. Minus 4 times 1 times 6 is -24 all over 2. X equals -5 plus or minus the square root of 1 all over 2. X equals -5 plus or minus the square root of 1 is 1 all over 2. So x is -5 plus 1 over 2, which is -4 over 2, which is -2. Oh, there's that solution. X is -5 minus 1 over 2, that's -6 over 2, which is -3. And there's that solution. And I know I'm going kind of quickly there. It's because I want to get into the more technical problems. But the point is, I could use the quadratic formula. Now, this is a poor example in that factoring it was way quicker. But I just wanted to do it both ways to show you that, yeah, the answer works. Not that one example is a proof, but just to show you that, yes, I got the same answer. Now I'm going to slow way down, take some more complicated equations, and solve them using the quadratic formula. Okay? So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. That's what we're going to use. Let me put on my glasses here. Let's say we have this equation. 6x squared minus x minus 1 equals 0. First of all, it needs to be in standard form. That's ax squared plus bx plus c equals 0. And it is. Okay. So now a is 6, b is -1, the coefficient of x, and c is -1, the constant term. So using the quadratic formula, plugging in the numbers for a, b, and c, excuse me, I get x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So I'm plugging in the numbers in the place of a, b, and c in the quadratic formula. Any questions yet? All right, so now I'm going to continue to simplify x equals, let's see, that would be a positive 1 plus or minus the square root of negative 1, the quantity squared is 1, minus 4 times 6 would be negative 24 times negative 1 would be positive 24 all over 2 times 6, which is 12. Need that to be quite so long. So then x equals 1 plus or minus the square root of 1 plus 24 is 25 all over 12. So then x equals 1 plus or minus the square root of 25 is 5 over 12. So now x equals 1 plus 5 over 12 or 1 minus 5 over 12. Well, 1 plus 5 is 6. 6 over 12 is 1/2. 1 minus 5 is negative 4 over 12 is negative 1/3. So x equals 1/2, comma, and 1/3. So there's two solutions to that second degree equation. Here again, we could have factored that, but eventually we'll look at some problems here that don't factor because we get some radical numbers like square roots of numbers that don't simplify. All right, we okay with this example?
Yes.
Okay. Let's see here. Let's take this one. T squared equals t plus 4. So I'm going to get this in standard form. I'm going to put everything on the left side of the equation. So I'm going to subtract t and I'm going to subtract 4. So I'm going to get t squared minus t minus 4 equals 0. Just like with factoring, it's best to have that leading term positive. So even though I could have just subtracted t squared from both sides to start with, then I would have had a negative t squared to the right, which means a would have been negative 1. And since the quadratic formula at the bottom, you divide by 2a, you divide by a negative, it's not as easy to deal with as if a is positive. So it's best to have your leading coefficient, your leading term positive. So put it on the side of the equation that makes that so. Okay, so now a is 1, b is negative 1, and c is negative 4. So actually we're solving for t now, not x. So t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. T equals 1 plus or minus the square root of 1 plus 16 all over 2, because negative 4 times 1 is negative 4, and negative 4 times negative 4 is plus 16. So t equals 1 plus or minus the square root of 17 over 2. Now, the square root of 17 doesn't simplify. So I'm going to get two answers, both involving the square root of 17. And in WebAssign, just as in the previous section, we have to list this. You can't use that plus or minus. So we're going to have t equals 1 plus the square root of 17 all over 2. T equals 1 minus the square root of 17 all over 2. Okay. In addition, we're going to go in and find the decimal approximation to the nearest hundredth. Okay. So again, just like in the previous section, when we talked about, I need parentheses here and there. I need parentheses here and there. So parentheses 1 plus the square root of 17, close up the square root with parentheses, close up the entire numerator with parentheses, divide by 2. I get 2.5615. We're supposed to round to the nearest hundredth. That would be the 6. The 1 would round down, so we're going to get 2.56 as our first answer. Okay. Now, 1 minus the square root of 17 all over 2, I get negative 1.5615. So again, the 1 rounds down, and I get negative 1.56. Okay, so those are the two decimal approximation answers to the nearest hundredth. So we've got the exact answers and the decimal approximations. Any questions on that one? Yes, question? Nope, okay.
No.
All right. Let's see here. This one says 3y squared equals 12y minus 4. So I'm going to put everything on the left side. I'm going to subtract 12y from both sides and add 4 to both sides. So I get 3y squared minus 12y plus 4 equals 0. So A is 3, B is negative 12, and C is positive 4. So y equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is a 4. So y equals negative times negative is positive 12 plus or minus negative 12, the quantity squared is positive 144. Minus 4 times 3 is minus 12 times 4 would be minus 48 all over 6. So y equals 12 plus or minus the square root of 96 all over 6. 144 minus 48, 96. Okay, I think I can simplify the square root of 96. Let's see. The square root of 96 would be the square root of 2 times 48, which is 2 times 2 times 24, 2 times 2 times 2 times 12, 2 times 2 times 2, 2 times 6. What do we got? 16 times 6. So basically 16 is the biggest square factor. So that's going to give us 4 square roots of 6. Okay, so 96 is 16 times 6. The square root of 16 is a 4 outside. So y equals 12 plus or minus 4 square roots of 6 over 6. So far, so good. Any questions there? All right, once again, actually, I'm going to want more room, so I'm going to take that whole mess and copy it on the next page. Y equals 12 plus or minus 4 square roots of 6 all over 6. Looking at this term, and this term, they're all even, so I could take a factor out of 2. So y equals 2 times over 2 times 6 plus or minus 2 square roots of 6 and a 4. Oops, not a 4. My bad. What goes there? A 3. Okay, you see what I'm doing there? To reduce it down. So there are the two answers. Reduced down. But now I'm going to separate them. And punch them into the calculator to the nearest hundredth. So again, I've got parentheses around the whole thing and around the radicand. So parentheses 6 plus 2 times the square root of 6. Close up the square root, close up the entire numerator divided by 3, 3.632. The 2 would round down, so 3.63 would be the first one. And then the second one is 0.367. That would round up, so 0.37. Okay, let's see here. Any questions on that?
No.
All right, what I want to do now is look at some things that we can do to sort of clean up the equation, make it easier to work with before we plug it into the quadratic formula. Recall things that are legal. You can multiply both sides of an equation by the same non-zero number. You can divide both sides of an equation by the same non-zero number, okay? You can clear decimals by multiplying by a power of 10. You can clear fractions by multiplying by the least common denominator. So let's take this example. Negative 5x squared plus 9x minus 2 equals 0. So here we have a quadratic equation. It's in standard form, but the thing I don't like about it is a is negative. So what I'm going to do, I'm going to multiply both sides by -1, which is going to give me 5x squared minus 9x plus 2 equals 2. And that's what I would take and plug into the quadratic formula. So a is 5, b is -9, and c is +2. Okay, so we can multiply both sides by a -1 to get the leading coefficient to be positive if it isn't already. Okay, another example. Let's say I've got 1.6, oops, let's go to the next page, 1.6 t squared plus 2.4 t minus 0.9 equals 0. Well, let's see. Each of these terms has one digit to the right of the decimal point. So if I multiply everybody by 10, I would get 16t squared plus 24t minus 9 equals 0. And now I could put in 16, 24, and -9 for A, B, and C. Now, you could use the decimals. You could use A as 1.6 and B as 2.4 and C as -0.9, but it's nicer to get rid of them first, I think. Okay, now let's say we have an equation with fractions. 1/8 x squared plus 1/2 x minus 3/4 equals 0. A is 1/8, B is 1/2, C is -3/4. I can tell you this, just about every student I know that has taken this and used the fractions and plugged it into the quadratic formula, they get into a nasty situation with all the fractions and it doesn't come out successfully. So let's get rid of the fractions first. How do you clear the fractions? You multiply both sides by the LCD, which is 8 in this case. So 8 times 1/8 x squared plus 8 times 1/2 x minus 8 times 3/4 equals 0 times 8. The 8's reduce out. X squared plus 8/2 is 4 times x minus 8/4, 2 times 3 is 6. So A is 1, B is 4, and C is -6. And that's what we plug into the quadratic formula. Okay, so we can clear the fractions. Finally, let's say we had this one, 33y squared plus 99y minus 66 equals 0. Well, we could factor a 33 out of the left side of the equation. We could then divide both sides by 33 and reduce it down to this. So now A is 1, B is 3, C is -2, and you'd plug that into the quadratic formula. So we can reduce things down, clear fractions, clear decimals, make leading coefficients positive. All these things can be helpful tools to make it easier to deal with the quadratic formula. And again, you want to get that quadratic formula memorized. Just remember, it's x or y or whatever variable equals -b plus or minus the square root plus or minus the square root of b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. And there you have it. I know what you're thinking. You're thinking, Mr. Mayo, keep your day job. Okay, and that's it, folks, for today. I'll be back this afternoon at 1.